that's easier than you think. Joshua, go ahead.
Hospital is having a good candidate so far. Um, Hopefully you're in the right room. I hope the filing is still a little bit on this. Unfortunately, we had a little bit of technical trouble, but I think they're still going to be on time. We do have a lot to talk about today. And there's going to be quite a bit of time for questions at the end. I just ask that you hold them, and I got to go through these slides pretty quickly here. So, when you hear this presentation, for some for office, stay. Okay, for some of you probably have a few questions in your head. You're like, Rust? Why? Why Rust? Why not this? Why not that? Why use Qt with Rust and all that kind of all those kind of questions? I just want you to hold those in your head for a moment and just let me trace you for a little bit. And I'm not trying to I'm not coming here to try to convert you to some kind of like Rust lover or Rust zealot or something like that. But I think this is something that we should really, consider. And I think a lot more people should be knowledgeable about this. So, what are we going to be talking about today? We're going to be talking about LibreOffice. We have, I'm going to try to split this up into kind of like two different sections here. So I want to go over sort of the non-technical, well, things that maybe like non-technical people understand and know about. And then in the later half, I'm going to go over the actual technologies that you can use to integrate C++, Qt, and KDE together. Hopefully, okay. So I just want to ask everybody a question. How many people in here raise your hand if you're interested in Rust? Okay, hold them. Drop your hands. Well, keep your hand raised if you know that there's already Rust inside of KDE today. Keep your hand raised if you know that there's Rust inside of KDE code right now. Before this talk. Okay, that's still a decent amount of people. So, hopefully this. Okay, yeah. So I explained. Since Rust is a relatively new thing, I was really curious if someone did a talk about this before in the previous academy. So there was three major instances that I could find. We have Tobias talking about Rust plus Flint in last year's academy, which of course I haven't been able to go to. The mom was talking about Rust in TG. And we also have a talk about Rust support in KDAB. So hopefully this is sort of a new talk to a lot of us here. And who am I? Who's the person you're going to be staring at for like the next hour or so? I'm Joshua Goins, also known as Red String on events. I'm a software engineer here at KDAB. You can see our nice little logo there on the front. And I've been hacking away on KDAB for a couple of years now. You probably know who I am. Hopefully. But I've been also using Rust outside of work for a lot of personal projects. And I find, of course, since I work in KDE, I really like to. So I'm really, really interested in how to glue those two things together, my two favorite technologies. Anyway, we're going to go into some surface level details about like what Rust is, sort of the purported benefits of it. In case this is going to be really quickly for people who already know Rust, it's going to be really boring. But for anybody who's not familiar, hopefully this will shed a little bit of light for you. So, what is Rust? It's a systems language just like C++ or C. It's relatively new. I think 1.0 came out in 2015. It's been in development earlier than that, but obviously it's pretty young compared to like C or C++. And a really big talking point, which we'll get into later, is safety. Rust is considered like a safe systems language, especially compared to C++. And it, on the surface level, it has a lot of similar syntax and concepts as C++, but of course there's some pretty big differences I won't be able to go over here. But what some other Rust features? We already know that it's safe. We already know that it's new and shiny. But what's some other like kind of benefits that people go on and on about in Rust? Kind of my favorite thing is that there's a lot of batteries included. So, for example, it has its own testing suite, as all those C++ developers and audience will know we have like a bajillion of those. So it's nice that they have standard ones. They're even working on a standard benchmark tool. We and also the product is in the suite. It has its own build system and package manager, which C++ also C++ doesn't. So that's kind of an interesting difference in between the two languages. Rust almost has a pretty large and rich standard library. I'll have to wonder again. It's probably not, I think out here it's not as big as C++, but it's still pretty sizable, I think. And also another thing I kind of love about this language is that it makes tool chain management really easy. A lot of obscure targets for like, I don't know, embedded, you have like WebAssembly and stuff like that. Stuff that we also have in C++ land, but I like that it's all centralized in Rust. Hmm. There's usually not like a bunch of forks of the Rust compiler that you have to use that are like a million years out of date. So, what's some of the kind of promises that Rust attempts to make? It tries to be more safe than C++. It does stuff like checks for memory safety, thread safety. It has much stronger ownership model, which we'll get into in the technical portion of the talk. But next, I'm going to talk about Rust and safety. Yeah, I have the same time I have. I did not even start this time, but that's fine. So, my show of hands earlier. Not that many people know that there's actually Rust inside of the KDAB today, but I just want to go over with you like KDAB is mostly C++ code. So why do we care about Rust at all? And I want to kind of go over like what can Rust bring to the table, and I just want to say don't ask why Rust and not X, Y, Z or your favorite favorite language you're on KDAB for that. But I feel like Rust is also kind of special because it has a lot of ways to integrate with C and C++. And since it's so similar, it's also a system language. I think it's a pretty good candidate if we want a second language or a third language to be count Python inside KDE. I think Rust is a pretty good candidate for that. And what's the next slide? Um, Something kind of the crux of my talk is there's a lot of talk, especially this year, about how can we attract new contributors to KDE. And if you ever been inside of I don't know, if you ever looked at what the new contributors saying when they were first contributing to KDE, a really common, like every few months someone asks us, why can I not use Rust? And in my opinion, I think Rust is a much more interesting language with contributors. I think, well, the thought process with them is that they think C++ is a legacy language. They think it's like a waste of time. Like, why should I even bother learning this? And I know for a lot of us in the audience, we would disagree. I disagree too. I think C++ is still modern enough. I feel like there's still a reason to learn it. But we can't deny this is kind of what people think. And if, for example, if they have if they want to contribute to open source, are they going to contribute to KDE, which forces you to learn C++? Are they going to go to another project that uses Rust because they might be interested in Rust only? So I think it's worth looking at Rust even for this point of all to try to attract new contributors. And I feel like we kind of see a microcosm of this already. For example, how many people here or how many people have you seen that only started off working in the QL part of platform or like a KDE application, and then they slowly but surely maybe they make like a C++ fix here or C++ fix there, and it's sort of like actively into the other languages inside of KDE. So I'm like thinking, maybe if we have a few Rust projects in KDE that people like to work on, and new contributors can go like, oh, I want to learn Rust. I don't really care about C++ that much. I'll contribute to this. And it's sort of just like the dominoes fall from there. And I'm going to go over a little bit of statistical data to kind of back up this claim. So this is an answer from the Stack Overflow Developer Survey from 2024. Uh, Also, just noting that I have QR codes for all the slides. I don't know how readable that's going to be to your phone camera, but that goes to, it's just a link on the slide, and there's a QR code as well. But I really don't like this section, but it's basically, let's see if I can place what it words here. This red part is what they call desire to use a language. So as you can see, this line here, right, is 82%, and blue line here is what I use it. If you actually use the language inside your data. So if we compare to C++, 82% of respondents want to use Rust, and unfortunately C++ is lower. It's like 53.1%. So that's a tiny bit lower. So I don't really trust this survey because it says 18% of people use C++ in their, like their daily work. But then they go ahead and say like 28% use Rust, which I don't believe at all. But I've only kind of seen here that even in a general sense, I think Rust is honestly much more popular than C++ right now. But C++ is still a lot. I feel like it's not going away in people's minds to give shots. But if we were to take this language here, I think we would use Rust, right? And this is kind of I think I've said much of this before, but uh, in the context of Rust inside a KDE, I feel like we're kind of in a special situation here. So to anybody who is pretty active in the Rust ecosystem, uh, and to let the people outside of it know, Rust doesn't really have a user interface library. For example, when you think of C++, and you're like, I want to write this C++ application that needs a UI, what's the first thing that comes to mind? It's Qt, obviously. But when it comes to, there's not really their own Qt. There's like a bunch of like different user interface libraries that they're developing. But since it's so new, it's sort of like a no man's land, where they're quickly trying to develop a solution, but there's like nothing like Qt. And so I think we can both benefit from this arrangement. If Rust needs a UI library and Qt wants attracting attributors, why don't we start Rust code? I feel like making it easier to write Qt-enabled Rust programs and sort of permeating Rust within the Canadian community can help both sides. And I'll get into this more later about how we can even use the inside of like Rust Qt apps. But I don't think it's really an unpopular opinion in this version that we want more people using Qt, but we want more people using Qt software. So we make it easier to use like Qt libraries like Kirigami or our translation framework from Rust, and we make it advertisable enough. I think people will use it, and I don't know, it can catch on the side of the West community and it can catch on the side of the Chinese community to kind of like benefit both parties here. So I also want to go over the kind of safety point for us because for PE, I feel like it's not too important. Of course, we do handle like a little bit of security stuff, but I think we generally make like that some software that doesn't really have to be secure. But that doesn't mean we still can't benefit from this point. For example, I'll go into this later. But for example, we recently inside of Conda, there's an optional Rust script that we can use for the HTML parsing that says if you enable it, it takes this real crashes. So I think I'll get into this more later, but I feel like a pragmatic approach to using Rust theory in this sense could be beneficial to Rust as well. I mean to KDE as well. So another point I want to go into is I personally don't care about the safety stuff too much when it comes to Rust. What's way more interesting to me is the things that people build in Rust. People build these libraries, what they call it, basically. There's like tons and tons and tons of useful things built in Rust. Um, um, but a little bit more how we can actually monitor those later. But I just want to show you what I mean with a really, really good example. How many people in here have heard of the servo language? Nice. So here's a really good case right here with Rust. So here at KDAB, we developed a QML component that if you use this on your QML application, will show you a servo web view. And this is sort of like the perfect case, right? Where if you don't know servo, it's written in Rust. But since it's quickly developing, they don't want to exactly commit to a C or C++ API. So it's going to be very hard for C++ applications to use it. So we can use Rust to kind of glue those two things together. And I'll go into what CXX-Qt is here. But that's kind of one of the examples of like a really cool Rust thing that we can then bind to and then use to try to Qt applications. It definitely would work, I think, for like normal C++ Qt applications. So if you want to use a server web view, I wouldn't suggest using that because that's just a prototype, but that just goes to show that there is uses for Rust even if you aren't a Rust consumer yourself. So another thing I want to avoid is I'm not here to tell you to rewrite your KDAB code in Rust. I also find that to be a pretty fruitless endeavor. I don't think I need to go on this point too much because I think the period, the honeymoon period was on. Everyone's rewriting everything in Rust. C++ code and start coding everything in Rust. I like to take a much more focused, pragmatic approach with that. So I think it's about time. Yeah, I think it's about time to start going into the technical bits of how to actually integrate these two things together. So how do we integrate Rust and C++? Real quick, I just want to go over how we've already done the integration on the KDE side. So as I already mentioned, Conda uses a crate for HTML parsing for security. In our Picasso drawing application, we also use a Rust crate for tessellation analysis to parse the game. In Angelfish, and I think Hangnail as well, we use an ad blocking crate. And put one to this. So clearly, KDE is not straight from us, and all of these will be using technology I'll go over in a bit. But since we're in the technical bit, I kind of want to give a good showcase of Rust safety for anyone who's not familiar with the ownership model, and just to give you the idea of like what are some of the technical and safety reasons why you might want to adopt Rust. And let's see here. Okay, so I'm going to give you a really constructed example in C++ of something that Rust kind of tries to paint over a little bit. So if you look here, I'm defining some class with formatting that LibreOffice decided to destroy. We have a method here called do your thing. We have a list of values that are integers, and then this do your thing has it calls to clear this list. And then in my main, I set the list from arrays to 1 to 5. And then I loop through those and print the values. But you see here, I'm changing the values too. And then I call do your thing. And for all the C++ programmers in the audience, you're probably screaming at me right now. You saying you should not do this. Because what will happen is it will invalidate your iterators here, and then this thing will completely explode. Here, the compiler for some reason printed through the whole list, and you can stop that too. But what I'm going to go into is like sort of what does this look like in Rust? If we try to rewrite the same thing in Rust, what does it look like? And here's the Rust version. So you can see we define the struct in Rust. We say it's a list of values. We also clear the values in this do thing function. We set the values to 1, 2, 3, 4, 5. You can't see the 5 because it's behind the bubble. Then we loop through the values. And we do the same thing here. When the value equals 2, we say do your thing. But can anybody tell me what happens here? Yes, and so I know my talk is a little bit of a mess, but this is what's really cool to me. So yes, you're right, it does not compile, and we can actually see the error message right here. And in my opinion, this is really cool. So this is part of what makes Rust safer than C++. And how do I say this here? And I feel like when people talk about Rust safety, they sort of pretend that you can't make safe C++ code. But it's not. I don't think it's as simple as that. I think it's just harder to write safe C++. For example, there's ways to make them previous C++ snippet like safer. Like obviously, you should be reading the documentation for a clear function to know that it actually has a really weird side effect. But the fact that Rust does not allow you to do it at all, it doesn't even allow all these unsafe errors to happen, is really cool. And so I would say even if I would say that when we're working with Rust as a C++ developer, it in in my experience is made me a better C++ developer because I've I've definitely written code like this before, and because the compiler or the optimizer sort of just like nothing errors out, no warnings come out. This stuff kind of like slips by, but with Rust it's really cool because it points out, hey, you really should not be doing this thing, this really unsafe thing. And I know this is kind of a prime example, but this is sort of my experience with when learning Rust is that it kind of makes me a better programmer in general. This even when I go back to C++, which I have to do, daily. And on that point, um, when it comes to this sort of safety stuff, of course, it's not a silver bullet. There's, for example, logic bugs are still very much possible, just like it is with C++. Um, even though there are security benefits here, I feel like when it comes to writing code in non-secure scenarios, it's probably a better idea if you're already using C++ to just learn how to write safer C++. And I want to quickly go through some of the libraries that we use to integrate this two technology. So I think I'm going to mention. Okay, I think I'm going to mention first is called Corrosion. So for we still okay. So when you integrate Rust in your projects, you probably still want to use CMake. But as you know, as I mentioned earlier, Rust has its own system called Cargo. So how you sort of unify those things? Obviously, you don't want to like call Cargo and then you sort of like manually link it in. So this is a really cool. It's a thing you can include in CMake that would basically allow you to invoke Cargo. So for example, if you have like a Rust function, I don't know, to code some user input data, you can just simply bring that little Rust library, include it in your project, then call Corrosion here, and it will auto build it, and it will also expose it as like a normal schematic targeted to just use like anything else. Of course, we want to build one on top of this. So how do we do that? We use a thing called CXX-Qt. It glues C++ and Rust together in sort of like this bidirectional fashion. So it's possible to use Rust types in C++, as if they were C++ types. And you can also do vice versa. And I will say this is very opinionated. So if you take a look at their website, they have a very specific way of doing things. But the point is to make it feel native on both sides and just to make you hate yourself for having to go through like the CFFI layer. And it also can like what is that? Function. What is it? It's like the yeah. Um, so a little bit of background is that I did it in the CFFI and I did myself. That's why I have a couple of projects that are also using compute, and I decided kind of incorrectly that I wasn't going to use CXX and I was going to create a C API instead. And I will say, please do not do that. Just use some crates like CXX. I'll go into a little bit, and I think, yes, in the next slide, I'll show you an example, a real world example of CXX code we had inside of KE. And it's, trust me, it's so much better. You want to use things like this. You don't want to try running C APIs. What's also cool is that it also handles C++ compilation. So, for example, if you did some C++ glue code, it will also handle invoking the they also handle invoking the compiler and all that fun stuff. So so I want to go into how simple this can be. So here, this is actually all of the Rust code that's in it on Pandai right now. And gluing these two things together. So obviously the HTML parts are pretty simple Rust. Just give it a string. So if we want to call it from C++, that's all we need. We define the function right here, and we say this function is from read HTML as bytes HTML.let. And then I don't have the C++ side, but it's literally just like one function call. And I just want to theoretically this can be simple. I just want to point that out that your life doesn't have to be difficult when you adopt Rust. Of course, this is a really simple example, but when you sort of get into more complex applications, you can kind of build it up. But this is not this is not an unsolved problem. I just want to put it that way. And now I'm going to get into this logic portion of the talk. This is all really cool, but this has nothing to do with Cube, right? So if we want to build Rust applications in Rust, how do we do that? We use a tool called CXX-Qt. It's created by our company, KDAB. It was created in about 2021, and it's still being maintained today by Andrew and Leon, and it's been updated continually ever since. We think this is the future of Rust plus Qt. We aren't the first people to do it, but in my opinion, we are following the most feature-filled and complete solution for using Qt in Rust. So I also want to mention that the maintainers are very receptive to contributions. This is, to be clear, this is not a product we're trying to sell you. We have CXX-Qt licenses or anything like that. There's also no CLA as well. So if you know a little bit of Rust and you want to try to help merge these two worlds together, that'd be very appreciated. Oh, and another thing I was told to mention is that CXX-Qt is still under development. But as you can see, it's still it is usable, but just keep that in mind that we're always trying to improve this thing. I said it was kind of unsolved problem version as Rust and Qt Rust and C++ together, but there's still ways to improve for the developers in this area. So now I'm going to go to an example of what CXX-Qt allows you to do, and I just want to make this disclaimer that this is really focused on the QML side. We don't have that much Qt widgets at all support in CXX-Qt right now because, as you may know, it's a huge C++ API. So we figured it's probably easier than if you have a predefined interface with like Q objects that you deploy with QML types that you write and slows the Q objects to like properly singles and multiples. That's probably a much easier place to start. But I want to say that it's not impossible to maybe write the Qt widgets application to Rust. I just will not recommend it, and I don't think there's many tools for that right now. So, for all the people who know how to write QML applications, you probably have a good idea in your head of like how to set up a Q object and how to attach properties to it and how to register it and stuff like that. And thankfully, in CXX-Qt, that's much similar. So you have to look through all the Rust systems right here. You can see in the very small type, sorry about that, that we have sort of the same system. So we have a Q object macro that you can call to, of course, register with the meta type system. We have a QML underscore element, just like in C++. You can define properties and stuff like that. And so I don't have it on the slide, but that you see right there, this my object Rust, that's just a normal Rust drawing set. So you can define like variables on it. If there's two even auto-generate properties for that. For example, this number is a number property. This my object Rust. You can also just do normal setters, getters, and singles and stuff like that. But really, this is all the glue code you need. And then the rest of the snippet, of course, will just be like normal Rust code. And so with this, you can build fully Rust QML applications today, just using this system. And even though there's a really simple example, we also support looking into Qt in much more ways. For example, you can, of course, create buildables, and those can be called from all three sides. We do it from Rust, from C++, from QML, of course. We also support inheritance. So whenever you have to create a Q abstract item model, we also support overriding the base methods. We also support, I was looking into the Qt events, the Qt threading system. We also support versus Q, namespaces, all that kind of stuff you expect. And of course, there's also a huge swath of CXX-Qt that's just exposing normal Qt core types like Q.F or whatever. And examples for all these can also be found in our repository. I'm not going to make you sit here while I flip through a million threading slides. But as I just said, I want to show you a real world example that I can use today, showcasing that you can write Rust KDAB applications, like a normal, like your normal QL applications that we have today in KDE. And I know I already said, please don't, start rewriting everything with Rust and don't start annoying people about that. I'm gonna make it one exception here. So who knows contrast, the simple QML map? Yeah, not that many people. It's like a contrast chart. You can like input two different colors or sample it from your desktop. And it's really helpful to find the colors that contrast enough so it's actually accessible and viewable by people. And so what someone has made is basically a Rust version of that. So that's something you can try out right now. You can see it uses Kirigami. It's the setting is a little bit funky, don't worry about that. But it's a good showcase because for simple, at least for simple QML applications, we have all the tools available. So this is fully Rust. There's no C++ in the repository at all. I'll link to the repository in the next slide as well. But I just want to show you, it just looks like any other regular application. There's nothing special that needs C++ here. So we have it's not that complex. It's like models involved, but you have like hue properties, of course, for color. We have signals because you have to be able to like change the hue, and that also changes the hex code and the actual contrast of the shows. We have the deliverables because of course the buttons have to do stuff, but it just shows that we already have all these tools to create Rust-enabled KDE applications. Someone just has to see how to do it. Here's a little bit more information about the project. I'm not the one who created it. It was Darshan in the KDE Rust room, which I'll also link to later in the slide. I'm just cleaning it up a little bit. And yeah, it's fully Rust and QML, no C++ involved. It's like a normal Rust project. So you just like include CXX-Qt and CXX obviously. And that's and And since this is a rewrite, we can actually do a little bit of statistical analysis about this. Even though I really don't like comparing lines of code between languages, I still think this is kind of interesting to go over. So obviously with C++, you have like a header and a definition file. In Rust, it's like one thing. So actually, this Rust rewrite is smaller than the contrast that we have right now. Of course, this is only like a simple case. I'm sure for bigger applications that actually might be different. But I mentioned that this also uses KDE technologies. So how do we do that with Rust? I haven't showcased that yet. It's called CXX-Qt frameworks. And just to clean the room, this is not supposed to be official in any sort of capacity or just like it's me. This is also created by Darshan, and I've been trying to help out a little bit with it. So like, for example, in that contrast rewrite, we still use Kirigami. We still use import add-ons for KDAB data. We still use the regular KDE translation system. So we all be binding that at Rust because you still have to do that in C++ and level QL applications. You can check it out here. It's not really complete. It really only has the bare minimum. But I also, I have a snippet of what the API looks like. So yeah, what's very similar to what you can do in C++ is that we have our boundary right here, our application domain. You can see it actually mines quite well to Rust during these concepts. Of course, we initialize the localization engine here. That's all normal. Ignore that really ugly line where I'm I'm not using multiple module. That's something I'm actually working on soon. But I also wanted to, I actually have some open questions about this project. So, do we even want this to become official? And if it does become official, I'm just putting that out there, um, what would the sort of layout look like? And I also curious, like, what kind of other frameworks might we need to worry about binding in Rust? Because of course I'm thinking like the next one to probably be like KDAB for configuration. Also, I wonder actually how much we actually have to worry about. And I also, if there's any distro people in audience, I'm really curious like what the situation with packaging and distributing Rust applications are. Because obviously, I think this is still pretty new. I personally haven't used the Rust+Qt application, so I'm really curious if there's like some sort of if there's like a huge roadblock or something that we might run into pretty soon that we might have to solve. So how much time do I have? Oh, perfect, because I'm wrapping up. Uh, so I know that was kind of a method of talk, but I hope you probably get the idea that not a lot of people know about Rust. Okay, I'm very sorry. A lot of people don't know that he already has Rust, and I think this is a real shame because I think this is the way to go. That more and more people want to use Rust, and I feel like we, of course, want games to survive even outside of C++. So I think it's worthwhile to think about this kind of things and encourage more and more people to use Rust inside of KDE and showcase that this is actually possible today. We just have to start about putting more effort. And here's also some more links. So, like I said, we're not trying to develop CXX-Qt as a product. So if you have any questions, technical or conceptual, they are available in the Zoom chat. This is also linked in the repository, so don't worry about losing this link. It's not the Rust Zula. It's a separate Zula chat. They're of course also receptive on GitHub. So if you want to raise an issue, if you're like, why does this work and why is this difficult, they'll gladly answer you. Also on the KDE side, we have a KDE Rust matrix group. I very much suggest, even if you have no interest in Rust at all, I suggest just doing that group because Zartan's working is fun off, and it's really impressive. And I think that's it. I think I'm gonna open up for a short question for what 10 minutes?
We have one that's it.
Oh yeah, one.
As long as it
Yeah, and hopefully they're off.
Great talk. So I was not aware that Rust is in KDE today. You mentioned that there are questions about packaging and so the development, which means the build system, also dependency management, everything that goes with it. And I fully agree with you that this is the kind of the yeah, probably most irritating or biggest hurdle to entrance to this. And you also mentioned two possible solutions to that, if I understood this correctly. Do you have more resources on that? What are people doing? Or if you have an idea for a tutorial or anything, we say, okay, well, this is where you can start, or this is the way that you can look into starting to set up some reasonable development workflow that doesn't end up in chaos with build systems fighting against each other in the end. Thank you.
I'm so for it. Like a little bit small part of it. The libraries that I mentioned earlier, Economy, Picasso, and something else. I didn't know fish. Those are good examples of how to just add a little bit small Rust without going insane and messing up your build system. And I sort of don't have the answer for you because I don't know if anyone's shipping a Rust a Qt application right now. On publicly on like a distribution. I would love to hear how to not make it But I don't have a good answer for you. Hopefully, once we're starting like working through a couple of ideas of like a real world application that's not gonna be right, that's not a toy, and we'll kind of cross that bridge when we get there. But hopefully, it's not a huge deal for packagers and
Okay. Okay. Any example with calling out into their HTML parts in another read, does that end up being statically linked or is it dynamic?
okay, this is a good question. For that, for the HTML parser, I would need it's actually totally possible since you dynamic. I believe if you build contents right now, it will. I don't think it'll try to statically link Qt and stuff like that. It will everything stay dynamically linked. It's a little bit more complex when it comes to Rust dependencies that are like old Rust and stuff like that, like the HTML parser. It's not impossible, I think, but it's I think when it comes to Rust, they're much more into like statically linking everything. It's sort of like bypassing everything you do in the shared linker. So as it's possible to do dynamic linking, but you have to sort of be cautious about it and make sure your dependency is supported and that kind of stuff. I'll bet connect to shared linking.
The question we didn't get it completely. To use origami, is CXX-Qt enough, or is CXX-Qt frameworks required?
You're asking if here, sorry, I don't understand your question.
The example you showed was using origami, right?
Yes.
And if I would want to write a Rust application using origami, is CXX-Qt enough, or do I need the CXX-Qt framework?
Because Kirigami is a tier 1 framework, it doesn't require any other framework, so CXX-Qt is enough. But of course, as a KDAB developer, I would suggest you use. But that's also the great thing, because if you want to use Kirigami in a QML application, then you basically have no reason to just write in CXX-Qt frameworks, right?
When writing libraries or frameworks, we normally care about the API. What's your feeling for the evolution of Rust in the direction beyond pure C API?
Sorry, so you're saying my feelings about something Rust is changing something while it's API? What do you mean?
More like it
Oh. So, if I understand correctly, do you think like it will start if we start using this in production, will like API issues sort of snowball into something greater? I would say that's probably not. I feel like that's something we're gonna go out in the hallway and discuss. That's also something I'm interested in. That's sort of like again with the packaging, it's something I feel like could use a little bit more. That's where I want. It could use a little bit more thought put into it. But I'm pretty confident it's a solvable issue. It's just an issue I don't know off the top of my head. It's huge. That's also something I'll go into the hallway. That's probably better to discuss. I don't, nothing off the top of my head. I'm not sure. This is also one of those things that we are. I don't think. I'm in the hallway about that. That's an interesting question. I can answer it for you, but I can't just do it right now. I don't. Nothing. I don't think anything should be a problem in that area. Like it's sort of like do the Python bodies that you have that issue? I mean, that's sort of the same idea.
Communities, so limits for them of quite a different level.